All right, in this problem, we're going to do the exact same equation we just did in the last one. Exact same equations, except now our interval is going to go from 0 to 8 instead of 0 to 6. Because in the last equation, what we figured out was our graph, in the last problem we figured our graph looked something like this for our f of x, and our g of x looked something like this. And we figured out they intersected at 0 and at 6. And the key to this, the key to all these problems, is you have to always do the graph that's on top minus the graph that is on bottom to get the area that is in between. So therefore, when I set up my integration, my first integral is going to be the exact same as before. If I'm integrating from 0 to 6, I'm integrating from 0 to 6, right? It doesn't matter. And the graph that's on top was g of x, which is 2x minus 1/3 x squared, right? All right, so there's that graph. But then we're going to also need the area now between the two curves going between 6 and 8, where f of x is on top. Well, how would you do that? Well, you would do it like you would anything. If I gave you two shapes and said find the area of the triangle, find the area of the circle, and find my total area, well, you say, okay, get the two and add them together, right? So same thing here. We get the area where g of x is on top. Now we're going to get the area where f of x is on top, which would be 1/3 x squared minus 2x. And we're going to integrate that from the boundaries of 6 to 8, where that area begins and ends. And then aside from that, the problem is identical. There's nothing that changes here, other than we just have to be aware of where our areas begin and end. So, excuse me. So the first part, because we already did in the other problem, it's literally the same answer. We figured out this was 12, right? So therefore, this is 12. The area does not change. So then now we just have to integrate the other part. So what is the antiderivative of x squared? Well, that would be x cubed divided by 3, all times 1/3, just like before. So this is going to be x cubed over 9, minus 2x squared divided by 2. So that gives us x squared once again. So, and you'll notice the antiderivatives are the same as well. Now the only difference is we have to just substitute in the values of 6 and 8. We just have to substitute in, all right, we have the 12 plus, and we're going to substitute in 8 for x cubed. So this is going to be 8 cubed divided by 9 minus 8 squared minus, now we have to substitute in the 6, which would be 6 cubed divided by 9 minus 6 squared. And go ahead and solve this however you like. You can use your calculator or whatnot. Or work it out by hand. I'm going to just pop this into the calculator and see what I get. I'm going to pause the video now. And I ended up getting those for my two answers. This piece right here turned into 64/9, and then this piece right here turned into the -12. And so now you'll notice here we have a 12 minus 64/9 plus 12. So 12 plus 12, that makes 24. And minus 64/9. And if we wanted to get common denominators, we'd multiply by 9. So let's see, 24 times 9. That would be 216/9 minus 64/9. So 216 take away 64, that would make 152/9. And so there's our answer. Or if you want it as a decimal, you absolutely can do that. That would be, well, the only thing I'd be worried about is this is an approximation, so it's not exact, but it'd be 16.8 repeating. So I would prefer the fractional answer because it's exact. But the big idea is if your graphs intersect and you're integrating over that intersection, you will have to break it up into two areas. The area where one graph is on top and the area where the other graph is on top. And then you just find those areas individually and you're done. All right, now, next idea is coming up. It's called finding averages. I'm going to get that in the next video. We'll see you then.